Hi, I am Lakshmi, Department of Mathematics, XNS College of Technology. Today we are going to discuss about the Cayley-Hamilton Theorem. Every square matrix satisfies its own characteristic equation. This is a statement for this Cayley-Hamilton Theorem. Here it is used to find positive integrals powers of A and inverse of A. So next we discuss about one sum. Here in this sum we are going to calculate verification and then A higher power and A inverse. So these three things we want to calculate. First thing, from this given matrix we can calculate the characteristic equation. So in this equation the d1 is sum of the diagonal elements is 6 and the d2 is sum of the minor of the diagonal elements, that is calculating the minus we got the answer as 9, and d3 is the determinant of A, that is the determinant of A is 4. So after that substituting all those values we got the cubic equation. So from this cubic equation using by Cayley-Hamilton theorem we can write this equation by in terms of matrix format. In this matrix format the constant we write with the identity matrix. So next in this equation you want to verify means we need the A square value and A cube value. We can calculate these two. So nothing, it is A square means multiply A into A and A matrix into A matrix, we get the A squared value, and A cube means A squared into A matrix. You want to multiply these two matrix and you will get the answer for A cube matrix. And after that, if you know these two values, next we move on to the next step, that is calculating the verification part. So verification means nothing is the left hand side values you want to write. The left hand side all those values, A cube value minus 6 into A square value plus 9 into A value minus 4 into I value. So all the values are we wrote, and then multiply. Just the constants take it to inside and multiply all the values. At last you just add all the values, add and subtract all the values, you will easily get an answer. The answer is equal to 0. So the equation equal to 0, the value is we got. So the equation is we verified. Next step is to calculate the A power 4. So A power 4 means nothing, it is we want to derive from it cubic equation. So take this cubic equation and in the A cube alone keep it in the left hand side, the remaining and all in the right side. So this way we got a cube value. So in this equation multiply by A and one more power is increased means you will get the A power 4 value. So each and every term we got the A power 4 value. So in this A cube and then A square and then A, all the values if we substitute and we get the same matrix addition and subtraction only. Here also we are doing. So at matrix addition and subtraction easily we get an answer for this matrix. Next step is to find the A inverse. So to A inverse means there is no inverse term in this equation. So if we want to calculate the inverse term means nothing, it is just divided multiply by A inverse in this cubic equation. So A cube we got from when you multiplying by A inverse, one power is will decrease. So A cube becomes A square becomes A, and A by A, that is identity matrix will get minus 4 into A inverse is minus 4 A inverse, which is equal to 0. Just to keep this A inverse in the left hand side, the remaining values in the right side, and this 4 also we can take it to the right side. So we get A inverse equal to 1 by 4 A square into 4A 6A plus 2I, sorry 9I. So in this as usual what we did before, the same thing we are doing, matrix addition and subtraction only. So here we are doing the A square value already we know. So that value we are substituting here, A squared value and A value, and then identity matrix. All the values are we are substituting here. So just to take this scalars to the matrix, multiply with this, and then again you will get a values for addition, matrix addition and subtraction. With this we easily will get a answer for this matrix. So here we got the answer as A inverse equal to 1 by 4 into 3, 1 minus 1 1 3 1 minus 1 1 3. This 1 by 4 is a determinant of this 4 is a determinant of A, and this value is a adjoint of A. Already we know the A inverse value. So if we compare these two, we get having this value. So thank you.